Okay, hello everybody. Today's lesson, we're going to go in and talk a little more about energy. Up until today, we have discussed kinetic energy and potential energy, different kinds of energy. Kinetic energy being the energy of motion, potential being the energy of position or stored energy in an object, and how those can convert back and forth to one another. And we've talked about something called the total mechanical energy, which is um, the total between the two, the potential and the kinetic added together. Today we're going to get into a little more about forms of energy. So I'm going to go into the folder for today's date. Today is the 7th of January. And the first thing I want to do before I start today is the PDF, Forms of Energy PDF. You are going to need that in your Notability. All right, so that's going to need to be downloaded to Notability from the folder. The video that I'm making right now, eventually it's not in there yet because I'm making it, but that's going to be in there when you look too. I also have the file for the Google Slides that I'm looking at now. I'm not sure if you're going to be able to open that or not. It really doesn't matter because you're going to see it as I go through it here during the video. So you're going to need to complete the PDF and watch this video as we go. So I hope that makes sense. So let's take a look at Google Slides. So we're going to talk about energy today. Okay, let's see if this thing works. There we go. All right, so here's a picture. And it says to identify all of the forms of energy that you see in this picture. So take a look around and see if you can identify any forms of energy. Okay, maybe you look at the cat who is bouncing off the walls in the door, right? That seems to me like kinetic energy, like mechanical energy, the movement of objects. You can look at the alarm clock ringing on the nightstand next to the girl in bed. Okay, and that's giving off sound that emanates out through the room. That is, of course, sound energy. Where else can we look? We look outside the window and we see the sun shining and its rays coming down and hitting the leaves of the trees, right? What kind of energy is that? That's light energy, energy in the form of light. You look out the window at the radiator under the window, and that gives off heat into the room, right? Heat is a form of energy. Of course, we call that thermal energy. Let's see, can we find any others? How about the apples? Look over on the dresser. If you guys see the dresser all the way to the right, there are two apples and a candle sitting on there. Now, if I eat an apple, what do I get from the apple? I get energy, don't I? That goes and I can digest the food and then use the energy in those substances. That is called chemical energy. It's energy that's stored in the chemical bonds of a substance. The candle is the same thing. Now, of course, me eating the candle, my body really doesn't have the ability to utilize the energy that's stored in the bonds of a candle. But if I light the wick, it's that combustion reaction is going to be able to get the energy out of it. So it doesn't work for me as chemical energy, but it still is. So food and fuels and things like that. So anyhow, those are some examples of these different forms of energy that we're going to talk about today. So we'll go through them one by one. Okay, so here's our question. How are the forms of energy going to be alike and different? Okay, so in our previous lesson, we learned that there are two types of energy, potential and kinetic, right? Potential is stored energy. It comes in a lot of different forms. It can be gravitational, it can be elastic, and it can be chemical. And then we have kinetic energy, which is when that energy is being utilized, the energy of motion. There are also many other forms of energy. This lesson will provide an overview of some of those forms, and we're going to look at those forms, and we'll get into them in more depth as we go along. Okay, so the ones we're going to look at today are these. There are many forms of energy. We're going to focus on just a few. Heat energy, thermal energy, mechanical energy, light, or what we call radiant energy, electrical energy, sound energy, and chemical energy. Okay, here's a graphic organizer. It says to record your information. Don't worry too much about that. Okay. Let's talk about the first one, heat or thermal energy. This is energy that is created in the movement of particles that produces heat. You guys might recall when we talked about changes of state back towards the start of the year, we talked a little bit about heat. And what happens if you heat up a substance is the atoms start to move more, right? And that's what we're talking about when we talk about heat or thermal energy. It's the movement of the particles in a substance, okay? It increases, thermal energy increases as temperature increases, of course. The faster the particles move, the greater the kinetic energy of the particles and the greater the object's thermal energy. Of course, the opposite is also true. If you slow an object's particles down, it loses thermal energy. Okay. Thermal energy also depends on the number of particles. If there are more of them, there is more thermal energy. Right. So if you have a substance in greater quantity, it has more thermal energy than something which you don't have as much of. Okay. Okay, when we say an object is hot, we're talking about an object whose atoms and molecules are excited and show rapid movement. A cooler object's molecules and atoms will show less. Okay, so hot atoms are moving. You remember that lab we did on PhET where we put the burner on and we had the particles that were in that little container and they started to move faster and faster and maybe they even blew the lid off the container if you heated them up too much. I mean, you guys have the idea of how this particle motion works. Okay, but it's all about atoms and molecules. So, which of these two has more thermal energy and why? This is kind of a strange question. Now, the obvious answer might be, of course, the hot chocolate, right? The particles in the hot chocolate are going to be moving more. What if we only had a very tiny bit of hot chocolate and a large amount of ice water? Is it possible that the ice water could actually contain more thermal energy? And the answer is yes. We've talked a little bit before. We typically think that ice is cold, and I guess it is, but ice actually is not anywhere near close to the point called absolute zero, where all the thermal energy in a substance is gone. There is still quite a bit of thermal energy. The particles in ice are still moving. So if I have a large quantity of ice water, it actually might contain more thermal energy than a very small quantity of hot chocolate. But for all practical purposes, the hot chocolate is the obvious answer here. Its particles have more thermal energy, per unit volume. Okay. Next type of energy is called mechanical energy, right? And this is the energy of moving objects. We basically worked with this yesterday in the energy skate park video. Now um, it can be in both forms though. It can be stored energy of motion, like when I roll a ball up a ramp and I'm holding it at the top where all that stored energy is there. All I got to do is let it go and it rolls down. And it can be when I let the ball go and the ball's rolling down the ramp, which is the kinetic side. But it takes into consideration both of those, potential and kinetic energy. Okay, mechanical energy can be all potential energy, all kinetic, or some of each, just like we saw in the half pipe yesterday. When it was at the top of the ramp, it was potential energy. When it was at the bottom of the ramp, it was kinetic. If it's halfway down, it's half and half. Okay, but mechanical energy is basically the energy of motion. All right. Mechanical energy of an object stays the same, but the potential and kinetic energy of the object can increase or decrease. Again, we looked at this yesterday on the energy skateboard. Think of juggling. The kinetic energy decreases until all the pins Kinetic energy turns into potential energy and just stops moving. Okay, there's my guy juggling. So as he throws the ball up in the air, if you follow, say, his right hand, he gives the ball kinetic energy, throws it up, and as it goes up towards the top of his head, it starts to lose some of that kinetic energy, turns into potential. Right above his head there, the ball has all potential energy. Its kinetic energy stops, but then it uses that potential energy as the ball falls back down into his left hand. Right, that potential energy gets turned back into kinetic. The mechanical energy of the ball, however, the whole time stays the same. The ratios of kinetic to potential are constantly changing, but it's not the total mechanical energy which remains constant. Examples of mechanical energy. Anything that's moving, right? So the skier, the ski lift, brings them up to the top of a mountain, and they have potential energy, gravitational potential energy at the top of the mountain, which they turn into kinetic as they come down, mechanical. See a swimmer who's using the energy that he has in his body and food to move his arms and create swimming motion, mechanical energy, and then the space shuttle moving through the air, launching into space. All right, next form of energy is called light, sometimes also known as radiant energy because it travels in rays away from things. Okay, light is actually created by vibrating particles. And these waves are called electromagnetic waves. Now, there's lots of different kinds of electromagnetic waves, and we can spend a week talking about them. Some of them we can see, right? And we call them light. Our eyeballs, our sense organs, our eyes are programmed to detect what we call light. There are lots of other kinds of waves which are very similar but are invisible to our eyes. Gamma rays, X-rays, microwaves, radio waves, and all that kind of stuff are all different kinds of electromagnetic waves, and all of them are forms of energy which are kind of in this, family. Okay, so light energy can be absorbed by objects, it can be transmitted, or it can be reflected off of objects. It includes energy from gamma rays, X-rays, ultraviolet rays, visible light, infrared waves, microwave, and radio bands. Again, those are all the different kinds of rays which are in what we call the electromagnetic spectrum. Examples of light energy. So there we see the sun in the top picture, transmitting its energy, comes to Earth in the form of light. It also comes to Earth in the form of a lot of those other kinds of rays that we can't see. It's not just light, but we see the light part, obviously. Okay, and down the bottom we see some other ones, radio waves. So if you turn your radio on in your car and all of a sudden music is playing over the station, it's because the signal is being sent on radio waves from a broadcast station, and your car is receiving it. Microwaves cook your food using a visible sort of irradiation. You got infrared, which is known as heat. The remote control on your TV is probably programmed with infrared radiation. Of course, visible light, ultraviolet light. They show the sun in that picture there because the ultraviolet light is what you put sunscreen on for. Right? It's a component of sunlight that causes some damage. X-rays, which I'm sure you're familiar with if you go to the dentist or you've ever been in the hospital for a broken bone, and gamma rays. All right, next form of energy. We have electrical energy. This is one that's utilized by human beings a good bit. It's energy that's carried by an electrical current. What an electrical current is the movement of electrons. Remember the particles of the atom? Subatomic particles, electrons, they're the negatively charged ones found outside the nucleus. They can move from atom to atom, and that creates what's known as electrical energy. People figured out a while back that electrical energy can be used. Right now we have this grid of high power transmission lines that run all across the country, and those bring energy into everybody's house, which is found at the electrical outlets. And then we can plug a device into those electrical outlets and do whatever job it is we want to do. You can turn your hair dryer on, you can make your washing machine spin, you can power your computer or whatever the case might be. But that is electrical energy that's found in those outlets. Okay, another kind of energy is sound energy. Sound energy is caused by vibrations. So my vocal cords right now are vibrating and sending vibrations out through the air. And that goes out in the form of waves, which would almost move out similar to like if you throw a rock in a pond and you watch the ripples move away from the place where the rock went in the water. Okay, and anything which vibrates transmits this sort of energy around it. If you've ever watched large speakers during a concert, something, you can see the speakers vibrate, and those are moving the air, causing these waves to travel out through the air. Okay. Chemical energy. So certain chemicals contain energy in the chemical bonds that hold the molecules together. When they're broken, that energy is released. Okay, so during a chemical reaction, sometimes the bonds of substances are broken and the atoms are sort of rearranged, and the energy that is contained within the bonds is released. So examples of these would be food, right? Anything you eat. The reason why we eat it, well, we eat for two reasons. One reason is because we want materials that we build our bodies with, repair. We want raw materials to build with. The other one is because we want energy. And so we eat foods that have energy in them, and then we digest them, and then that's carried by the blood to our cells, and our cells will take those individual molecules and then burn them, essentially, and break them apart, and the energy that's contained within those, the sugars, is released so that the cell can do some work. Okay, so foods. A battery is chemical energy, so batteries have certain chemicals in them that make them function. Candle or wood, right? Fireworks, fossil fuels, anything you call a fuel, pretty much. Gunpowder, that sort of stuff, obviously has high levels of chemical energy. Examples, there's a piece of coal in the top left, okay, which is actually a substance that's found under the ground, and that contains energy. So it can be burned in a furnace or to make electricity. When the energy is released, you got a Duracell battery there. That creates electrical energy, but it creates electrical energy because of the chemical energy contained in the battery. And of course, cotton candy, big bag of colored sugar, contains some energy too. Believe it or not, it's certainly not a recommended food to eat in large quantities, but pure sugar, right? So sugar molecules contain energy within them. All right, so let's think about a few examples just to go through and review. What type of energy cooks food in a microwave oven? All right, and the answer is radiant energy, which is also similar to light, right? Sometimes we call that light energy. Um, those waves come out and they hit the object that is in there and cause the atoms to vibrate. They energize them, giving them heat, right? Creates thermal energy. What type of energy is the spinning plate? Well, it's moving, right? So the moving object, the spinning plate in the microwave, is mechanical energy. Okay, we got an outlet in the front, or the top picture, rather. What kind of energy is that? Electrical, right? Moving electrons. It's there at the ready. All we got to do is plug it in. Okay, when we plug a fan into it and the fan starts to spin, that electrical energy gets transformed into the moving object would be mechanical energy. How about a tree? That doesn't look like a heck of a lot of energy just sitting there. But what do trees have? Trees have leaves. Those leaves are basically little solar panels, right? So the sun comes down and strikes them, and you may have heard of this process called photosynthesis. And trees are able to take the energy in sunlight and turn that into energy which is stored as a molecule called glucose or sugar. And that is the basis actually for all life on Earth, is that chemical transformation right there. But we have light or radiant energy, the sunlight coming down, and then of course we have the chemical energy that the tree is making and storing inside it. Okay. What types of energy are shown below? We have a remote control. Person's looking at the TV. Well, probably in the remote control to make it function, you're going to have batteries, right? So your batteries are going to be an example of chemical energy. When I am hitting the buttons and the TV is responding to my sort of commands that I give it through the remote control, that signal is traveling from the remote to the TV through radiant energy, right? Light energy. I think it's actually infrared that they use on remote controls, but it is a form of radiation that's traveling. Okay, back and forth. Of course, we have, what do we say? Chemical energy in the batteries. We got some light, radiant energy. We certainly have electrical energy being used. The TV is obviously going to be plugged in. Okay, so here we go. Chemical, mechanical, and radiant. I didn't mention mechanical, actually. I guess that's the movement of the person's fingers to actually press and create mechanical energy. All right, what type of energy is shown below? It looks like a coil on a stove. How about thermal, right? Heat energy, thermal energy. Type of energy is shown below. It's a tomato. Okay. Chemical energy. Yummy, huh? Um, the molecules in the tomato contain energy, right? So we consume it. Our bodies can burn that fuel, and types of energy are shown below. We got, well, we got mechanical energy, the energy of motion, the person pushing, and of course, why thermal energy that it says here? Because of friction, right? As the person pushes the box over the surface, there's going to be friction created between the box and the surface, which is going to create heat. You might mention here where's the energy coming from that the boy or the person is able to use to push the box, and that would be chemical energy stored in his food also, if you want to throw that one in too. Okay, so in the world around us, and we're actually getting into this a little more tomorrow, energy is transforming continually between one form and another. Often one form of energy changes into more than one form. So again, the rule, and we'll talk more about this tomorrow, law of conservation of energy. Energy is transformed. It's not created or destroyed. It simply changes from one form to another. Think about that a little bit today as you look around, maybe, and think a little bit about energy in your surroundings. See if you can identify some places where you see some of these forms we've discussed and um, how they're changing. Okay, so we're going to actually leave this alone here today, and we'll get into some more of this tomorrow, maybe the rest of this slideshow. But what I want to do now is go into Notability, where I have already downloaded the PDF file that we are going to look at and do today. So let me get out of this. I want the Forms of Energy PDF, right, which was found in today's folder. And we're going to look at this together. So energy exists in two states, which we talked about yesterday. It can be kinetic and potential. It's hard to fit in that box. Okay, all energy can come in those forms. The energy that is actually being used is the kinetic energy, and the stored energy that might be there but not currently in use is called the potential energy. Okay, it also can be into other forms which we discussed today, such as electrical, thermal, chemical. I don't know whether I should write sideways or down, how to fit these things in here. Sound, light, which is also referred to as radiant, right? Radiation, energy, and mechanical. And there are some other forms too, like nuclear energy is another form of energy. That we didn't put. So we could probably put more on here if we wanted to. Um, and of course, there is the law of conservation of energy, which is an important law that states that energy is not created or destroyed. It simply changes from one form to another. So if you take the universe as a whole, it is neither losing nor gaining energy. It's got a constant amount of energy, and that energy might go from one place to another and change from one form to another, but the overall amount of energy is going to be constant. Okay, so after we do that together, here's what I would like you to do with the remainder of your time. I would like you to read this. This is called the Introduction to Energy here, and it goes through what is energy, forms of energy. Please read it, highlight it if you will. Go through the different forms of energy and read the information that's on this page. Okay, and the next. And then complete this worksheet here. Okay, it's a fill in the blank. It says you can use the words more than once. So let that sink in there. You can use the words more than once if you have to. And here's your word bank down here. Okay, when you get done with that, I'm going to have you submit that to an assignment in Schoology that'll be graded. Okay, so please get that done. Have a great day. Let me know if you have any